Welcome back, Caymans. Mr. Eicher here, coming at you with the part 2 of a 3.1b lesson we did in the last video, solving systems algebraically with substitution and elimination methods. In this one page of notes here, we're going to look at 2 word problems. You're going to be having some word problems like these in future lessons. So let's take a look at this question number 3. Carrie is responsible for checking a shipment of technology equipment that contains laser printers that cost $700 each and color monitors that cost $200 each. She counts 30 boxes on the loading dock. The invoice states that the order totals $15,000. Write a system of 2 equations that represents the number of each item. Be sure to specify what each variable represents. So it looks like we have laser printers, which is an unknown amount of how many laser printers there are, and we have color monitors. So we'll let X be the number of laser printers, and we'll let Y be the number of color monitors. You could have used L and M if you want. You could switch these if you want, but as long as you define which one's which, we're happy. And there's 2 pieces of information here. There's a piece of dollar amounts. So like looking at these units, these dollar amounts. It'll be really helpful as you do this chapter to think of the phrase collect similar units. So for instance, you have these dollar amounts that we're highlighting in yellow. If I collect those, I could write an equation based on those similar units. We have a laser printer X is $700, so that would be 700X plus they're $200 per color monitor, so $200 per Y, and that equals the total amount of money, which is $15,000. The next similar unit is total boxes. So we have 30 total boxes, and some of those boxes are laser printers, and some of those boxes are color monitors. So if we would add our laser printers, which is X laser printers, plus Y color monitors, we would get a total of 30 boxes. So right here is our system of equations. And then part B asks, how many laser printers and how many color monitors were delivered? Well, we can use one of our previous methods, either substitution or elimination, to solve. So maybe we'll try to fit both on one page. We'll start with substitution. The substitution method would say, hey, take maybe this second equation. I have a 1x right here. And if I solve for x, I would get x equals 30 minus y. And I'm going to take that 30 minus 1, I'm going to plug it into the top equation where that y is. So I'd have 700x, or sorry, we solve for x equals 30 minus y. We're going to take the first equation and we're going to plug that x where that x is. So we'd have 700 times 30 minus y plus 200y equals 15,000. So distribute the 700, we would get 21,000 minus 700y plus 200y equals 15,000. Subtract 21,000 from both sides and add like terms, so that would be negative 500y equals negative 6,000 divided by negative 500, and that would be 12. So we know there are 12 color monitors, and if it adds to 30, there must be 18 laser printers. So that's using the substitution method. If we use the elimination method, it would look like this. So the elimination method, we would have maybe this bottom equation, multiply that bottom equation by negative 200. So I'm going to keep the top equation exactly the same, but the bottom equation I'm going to multiply by negative 200. Both sides, negative 200. So that would be negative 200x minus 200y equals negative 6,000. And then when I add down the columns, I would get 500x plus 0y equals positive 9,000. So then divide by 500 and I would get 18, and that's 18 X's. That would be 18 printers, and since there are 30 total, that would be 12 left over for monitors. And this is the same answer we got with the substitution method. So either approach is viable. You can pick whichever one you like better, but substitution and elimination, both approaches work to solve systems of equations. And you can decide which one might be easier for you. Sometimes it's easiest to use substitution when you have one like this, that the coefficient in front of those are both 1. But you could always use elimination too. Let's look at the last one. Mr. Montgomery is writing a test for his A-Push classes. The test will have true-false questions worth 2 points each, and multiple choice questions worth 4 points each, for a total of 100 points. He wants to have twice as many multiple choice questions as true and false. So let's think of the collect similar units again. So we have points. We have 2 points, we have 4 points, and we have a total of 100 points. So one of our equations we write is going to be the points equation. But maybe I'm ahead of myself. I should probably define my variables. So let me define x. We'll let x be the number of true-false questions. True-false questions. And we'll let y be the number of multiple choice questions. And we'd like to know, as you can see from this question, how many of each type of question. So that's what we're being asked. That's our variable. So let's write a points equation, collecting those units of points that we have highlighted in yellow. So there are 2 points for every true-false question, plus there are 4 points for every multiple choice question, and he wants it to be a total of 100 points. Now, if that's all the information we have, then there's a lot of different ordered pairs that would work. Like he could have 50 true and false and no multiple choice. That would be a total of 100 points. He could have 25 true and false, and, well, that might not be a nice round number there. He could have 10 multiple choice. That would be 40 points, so then that would be 60, so 30 true and false. So whatever combination he wants, like if that's all that we knew, there's a lot of different combinations that would work. But we're told in this last sentence, he wants twice as many multiple choice as true and false. So we want our second equation to be twice as many multiple choice. So let's think about that. If we have multiple choice, we have true and false. If you want twice as many multiple choice, that would be like 50 multiple choice compared to 25. That's twice as many multiple choice as true false. Or if he wants 10 multiple choice, that would be 5 true and false. So the multiple choice is y, and the true and false is x. So the relationship here would be the y column. If this is x, this is double that. That would be 2x. So the number of multiple choice he wants needs to be twice as many as the multiple choice. So this column is 2x, and that's our multiple choice y. So we would have y, the number of multiple choice, needs to be double that of true and false. Y equals 2x. So if you have 10 x's, if you have 5 x's, that's going to be double 2x is the number of multiple choice. So this would be our system of equations, and that's what you'll be solving for a try this on part B. So use the substitution or elimination method to solve for how many multiple choice and how many free response questions there are in this. Thanks for watching this video. I'll see you next time, and good luck with those try this questions.